All right, good morning. So, hello and welcome to our breakout session, assessments, which is about using technology to enhance safety at scale. I'm connecting with you today on the traditional and ceded territory of the Squamish, Tsleil-Waututh, and Musqueam Nations. I am Janice Lee. I'm the Director of Product and Market Leadership and your host for this session. So let's get to it. I'd like to introduce Lisa Pitcock-Lee, who is our Director of Operations, who will talk to you about our approach to assessments this morning. Thank you. Lisa?
Thanks so much, Janice. Good morning, everyone. It's lovely to see the turnout for this session on assessments. As Janice said, I'm Lisa Peacock-Lee, and I'm the Director of Operations. I look after assessments at Technical Safety BC, and most of you will be familiar with our safety officers who play a critical role in evaluating technical systems and processes for potential risks and hazards. You heard earlier from our board chair and LEO that it was a challenging year for many, and these economic times also impacted us. And as we navigate an increasingly complex and changing landscape, it's become evident that technology can help enhance the capabilities of our safety officers. So for this session, we'll delve into assessments and the use of certain technologies like machine learning and remote assessments. We're going to start with how we conceptualize assessments as part of the safety system. Next, we'll look at what risk-based oversight means and how it helps us to allocate our assessment resources in a structured way. We'll go behind the scenes with machine learning and remote assessments. And then I'll show you some numbers that I look at on a regular basis so that you can assess for yourself what it means to use technology to enhance safety at scale. So with that, let's get started. The goal of Technical Safety BC's assessments is to improve the overall well-being of British Columbians. It's about building trust, and we want British Columbians to be able to trust that they can turn on their lights and adjust their temperature settings without worrying that their house is going to burn down, and that they can get on an elevator at work or go skiing over the weekend and the lift systems will function properly. And that when they and their kids get on a roller coaster ride to scare themselves silly, that they aren't really in any danger. Assessments play a pivotal role in safety compliance, evaluating risks, and mitigating potential hazards, so that British Columbians can trust that their lights, furnaces, elevators, ski lifts, and many other technical equipment will function properly, so that roller coasters provide exhilarating but safe experiences. Safety officers examine equipment, systems, and procedures to confirm that they meet or exceed the prescribed safety requirements. As you can imagine, assessments require significant time and resources. And in an environment with ever-evolving technology where things happen at the pace of crisis, it can feel difficult to keep up. Even though we're the regulator, I can tell you that we face many of the same constraints and obstacles that industry faces. Quick turnarounds, lots of rules, supply chain impacts, having the right people doing the right things at the right time, and the list goes on. We frequently need to make choices on what gets assessed by safety officers and what doesn't. Should a safety officer look at an electrical installation completed by an inexperienced homeowner? What if it's only the screws on a de-energized panel? What about a boiler system in a hospital, or confirming that a pipe has been painted the right color? And how confident do you feel getting on the wooden roller coaster at the P&E? Today, we're going to talk about how choices are made on what gets assessed by a safety officer and what doesn't, and how we've used technologies like machine learning and remote assessments. Before we talk about how choices are made on what gets assessed by a safety officer and what doesn't, however, I want to share with you how we at Technical Safety BC conceptualize what we do. The safety system is big. There are 4.8 million of those British Columbians I describe going about their business every day. And of course, I don't need to tell all of you that technologies we regulate are very different from one another and they pose different risks. An electrical installation isn't a gondola. An ice rink isn't like an elevator. The safety system is big and it's also complex, and Technical Safety BC is relatively small. There's no feasible way for our safety officers to assess all the technical equipment in the province firsthand. That would require us to be everything, everywhere, all at once, which makes for an arguably great movie, but also a terrible oversight model. Can you imagine the cost of a permit if we did that? So we use a visual model to think about what we do. We often describe our role as productive friction in the market, and that job is tricky. We need to get in the way enough to make sure that technical equipment operates within an acceptable margin of safety, but we can't get in the way so much that we are an unnecessary burden. That becomes what we call unproductive friction. So we have a very large and complex environment and a relatively small organization. And one thing we know for sure, or maybe just for now, because who knows what the future holds, technical equipment doesn't make decisions for itself. But skilled design and deployment are necessary. Entropy and wear and tear are real. That businesses buy and sell things is true. The countervailing forces of time and money are powerful, and it takes a human to make a choice in order to keep British Columbians safe. That's a challenge. And it quickly becomes evident that these safety-related choices vastly outnumber our safety officer resources, which is why everyone in the safety system, from qualified workers to owners to Technical Safety BC, needs to work together for the safety of British Columbians. So breaking the model down, I want to start with the rings. The rings represent the concept of professional reliance. In the center, we have British Columbians and the systems they are interacting with every day without any intervention. The next ring represents qualified workers, individuals who are skilled and qualified, sometimes by us, sometimes by other agencies, to design, engineer, install, repair, and otherwise do work on these systems. The darker gray ring represents the organizations that employ these workers, and Technical Safety BC is on the outside, furthest from British Columbians, but an important boundary for the system. The qualified workers in the light blue ring and the organizations they work for are relied upon to do their part, to ensure work is executed against codes, to provide advice and make decisions based on their expertise, to maintain their equipment to a standard, and to protect themselves and other people from harm. That said, a reliance model goes beyond simply expecting an individual or organization to competently apply standards and follow rules. It requires them to exercise professional levels of discretion, care, and due diligence. This includes many of you here today, our partners and clients. You have direct and frequent interactions with equipment, the skills to do the work, and expert judgment to do it well. Your participation and good judgment are crucial to the system working as it should. So now let's move to the wedges. Each wedge in the model represents a life cycle stage that we've identified through our incident investigations and assessment data. You could call them moments of truth for technical equipment. These moments of truth are pivotal decision points where a bad choice can end up with someone getting hurt. Incident data shows that bad things happen throughout the life cycle of equipment, but most often at the beginning and end of its life. In the beginning, we see that design and installation, if poorly executed, can create hazards and lead to incidents. This is an ongoing threat because technologies are constantly evolving and moving forward. And in addition, large systems tend to be unique. What was designed and installed a year ago for a specific purpose might look quite different this year or next. It's also been shown through our incident data that it's the decisions made throughout the life of the equipment that can influence what happens at the end of the life cycle. Was the equipment altered for a different purpose? Did the owner lose track of the equipment's state? Was it properly replaced and disposed of at the end of its life? And was the system maintained relative to its changing context? Different technical systems require different interventions at different stages of their life cycle. And it is often that context that drives the need. Usage, complexity, environment, investment, and again, the expertise, attitudes, and beliefs of the people with greatest proximity. No piece of technical equipment exists in a vacuum, and the context in which it finds itself can contribute to greater risk as it changes. So now you've seen the model broken down into its two main components: people and technical equipment, rings and wedges. Now we're going to talk about how assessments fit into this model, and specifically risk-based oversight. In a risk-based model, planning and execution are both focused on managing risks. It's a way of performing oversight where planning is driven by the combination of risk profile and safety performance, and execution focuses on the management of risk in addition to promoting compliance. Risk-based oversight helps to prioritize assessment activities and optimize the use of resources. In my earlier questions, many of you would have likely agreed that you'd prefer a safety officer to inspect a boiler system in a hospital over confirming that a pipe has been painted the right color. We intuitively understand that the former is more likely to have greater risks. Our risk-based oversight model relies on the competence of contractors and others, so our safety officers don't complete inspections on every installation of regulated equipment that occurs. We physically assess a limited number of sites in order to monitor the compliance of the individuals responsible for doing the work. And a key element in the success of our inspection program is targeting sites where there's more likely to be an elevated level of risk. I sometimes hear that our safety officers should inspect everything. Why must there be a choice between the hospital and the pipe? Both are important. We need more boots on the ground, and people aren't seeing enough of our safety officers. This is called a compliance-based model, and it requires inspecting everything all the time. If Technical Safety BC was to switch the technologies that we currently assess according to a risk-based model to a compliance-based model, our permit fees would need to be about 5 times higher to fund the additional resources needed to do all those assessments. I don't think the safety system could bear this cost. And as a homeowner who uses some superstar contractors, I don't think the increased costs will lead to better safety outcomes. I think the pricier permits would drive people out of the safety system and lead to worse safety outcomes. I want to share an analogy that many of you as parents might identify with. Have you ever had to teach a child how to do math? In a compliance-based model, you as the adult sit with the child and supervise them to answer each and every question. After they've completed their questions, you go back and review each of their answers to confirm that it's correct. If there's a mistake, you identify it, review it with them, wait while they make the corrections, and repeat the process until they get it right. After a few rounds, you might add another step. Pray that they get it right because you can't handle another round of this. In contrast, in a risk-based model, you don't check all of their work. You trust that the child is learning math at school, that mistakes can and do happen, and that your role as an adult is to spot check and meet them at their needs. Sometimes this looks a lot like compliance based work, and you need to maintain a high level of presence. Other times, however, when the child is excelling and math has become their favorite subject, your role is mostly to stand back and see what they can do. In these circumstances, a compliance-based model adds unproductive friction, and you're more likely to become an unnecessary burden. So let's go back to our risk-based assessment model, one where Technical Safety BC creates productive friction and does not become an unnecessary burden. We're not inspecting everything, we're inspecting a subset. and the framework we use to assess potential hazard levels and direct assessment efforts is called structured resource allocation, or SRA, and it uses machine learning technology to enhance the expert knowledge of safety officers. SRA was developed to help supplement the judgment of safety officers in deciding which sites to inspect. And within SRA, there are 5 channels that drive assessments. Every permit receives a machine learning score based on project risk, contractor performance, incidents, and a host of other variables. Higher scores are deemed mandatory and will receive either a physical or remote inspection. Machine learning assists in prioritizing inspections with the highest system-derived probability of identifying high hazards. It detects patterns and data from when permits are pulled, as well as safety performance data, and uses this to make increasingly accurate predictions. To increase our understanding of potential hazards and risks and improve our machine learning algorithm, we also develop sample plans. With sample plans, our safety officers will inspect a limited sample of permits for a specific type or segment of work or equipment. By using data science protocols, it's possible to draw conclusions concerning many pieces of equipment by inspecting a limited number. Then, where we have very low risk tolerance for an incident, we have also set up policy rules that require our safety officers to inspect the work, regardless of the machine learning score. Examples of this would include gas work in schools or hospitals. For permits that don't require an inspection through any of the other channels, we rely on our safety officers using their knowledge and expertise to flag and inspect any other permits that they assess to have the potential for higher hazards. I think it's crucial to recognize that our safety officers remain at the forefront of our efforts, and most assessments are acted upon according to their judgment. The capabilities offered by technology are combined with safety officers' understanding of safety principles, regulations, and operational context to help drive improvements in safety outcomes. The technology doesn't replace them, but helps them to expedite decision-making. And then lastly, hazard eliminations are notifications that we receive via the public, clients, or other stakeholders alerting us to a hazard. These do not necessarily have a permit and don't receive a machine learning score. All of these are inspected by our safety officers. So the SRA program directs the majority of Technical Safety BC's assessment resources. It enables the identification of the most serious hazards, structures samples to understand the safety levels of specific participant segments, validates approaches for addressing risks, and maintains the presence of safety officers throughout British Columbia. It's been effective in identifying sites where high hazard noncompliances are more likely to exist, and later I'll share data showing that sites selected by the SRA program are more likely to find high hazards when compared to inspections done at sites selected only through safety officers' discretion. So that's a lot of information and a behind the scenes look at how assessments are dispatched and their function in Technical Safety BC's risk-based oversight model. What does it look like from the end of those doing business with us? When declarations are submitted and an inspection is requested, the information is processed through the SRA program. For example, an electrical installation has been completed in a residential home. Let's say a contractor has submitted the declaration and the information has been processed through the machine learning algorithm. If the contractor has a positive history of compliant work, the machine learning algorithm will likely generate a score below the mandatory inspection threshold. Assuming there are no policy rules that would make it mandatory to inspect, the safety officer can now conduct a risk assessment and may decide to accept the declaration to pass the work. Alternatively, perhaps the safety officer is familiar with this contractor and is aware that the business has recently changed hands. The new owners have not been as diligent with code requirements, and although the machine learning algorithm has not required a mandatory inspection, the safety officer may still apply their discretion and conduct an inspection. Now, let's say the residential electrical installation has not been completed by a contractor, but by a homeowner. Technical Safety BC has a low risk tolerance for uncertified individuals and recognizes that work performed by these individuals tend to carry a greater risk. If we think back to the rings and wedges of the safety system model, this work is missing the ring of qualified workers, which requires us at Technical Safety BC to act as a stronger boundary. Accordingly, there's a policy rule that requires all homeowner permits to be inspected. The safety officer would then inspect the work that's been completed by this homeowner. This is why you'll sometimes see safety officers, but not always, after requesting an inspection. Some activities may be considered low risk and therefore may not require frequent assessments or oversight. In these cases, safety officers may only conduct assessments periodically or when there's a specific concern or complaint. In other cases, safety officers may conduct inspections remotely by reviewing the declaration and materials submitted, or they may conduct a virtual assessment using video conferencing like we're doing today. This brings me to our assessment continuum and the use of remote inspections. When we talk about assessments, we're referring to a broad spectrum of activities. In operations, these activities are usually in response to installation and operating permits. Starting from the lightest touch on the left, the system assesses the permit and predicts the level of hazard, which we've talked about in previous slides. If we could get the slide deck to show the rest of the content, that would be great. If the permit is assessed as low hazard, we may choose to review and accept a declaration of compliance from the client, which may include review of photos and documentation. In other cases, a remote or physical inspection may be performed. A remote inspection can be conducted in real time to build on photo and document review. Compared to physical inspections, remote inspections offer significant savings in travel time and costs while also expediting access to safety officers. We typically perform physical inspections of the highest hazard permits. These inspections can require a significant investment of travel time and effort by our safety officers and are necessary for poor performers, complex projects, and in some cases to collect data to increase the accuracy of our machine learning algorithm. At the far right of the spectrum, we have audits, which differ from inspections in that they focus on a client's systems and processes rather than just the completed work. As you can imagine, with all the different technologies that we regulate and their various risks, we have hundreds of assessment types. Whether it's electrical vehicle charging stations, food trucks, ice rinks, escalators, gondolas, or water slides, this continuum is a toolkit of the types of assessments that safety officers might perform. Now, the big question is, does it work? Does using technology like machine learning and remote inspections bring us closer to the goal of improving the overall well-being of British Columbians? Here's where I want to share with you some numbers that might be helpful for considering this question. This is a graph of some key assessment metrics. You'll see at the bottom that the information is presented in quarters, starting with the first quarter or Q1 of 2019 and extending to the end of last year. On the left of the graph is what we refer to as hit rates. When safety officers conduct inspections, they record information on what they find on site. When there are non-compliances, safety officers assign a hazard rating to what they found. These hazard levels range from 1 to 5, with 1 being the lowest hazard and 5 being the highest. So, for example, if a safety officer finds a gas appliance that requires operating instructions and there are none, a non-compliance with a hazard rating of 1 might be assigned. It's not compliant, but it's also not so unsafe as to be urgently concerning. On the other end, if a gas appliance is being used indoors and there isn't proper venting, people might die. If in this latter scenario, a safety officer would likely assign a level 5 hazard rating and likely won't leave the site until the hazard has been made safe. We refer to safety officers finding non-compliances as hit rates, and we are particularly interested in the higher hazard hit rates or the non-compliances assessed at levels 3, 4, and 5. These suggest our safety officers are going to the right places at the right time and identifying risks before they become hazardous incidents. So we watch these numbers closely and look to improve our overall hit rates. The two lines on the graph indicate the high hazard hit rates. The red line refers to levels 4 and 5 hazards, and the blue line refers to levels 3, 4, and 5 hazards. Looking at the chart, you can see that for every 100 inspections, safety officers will find a level 3, 4, or 5 hazard at about 9 inspections. This is based on safety officer knowledge and discretion. Now let's look at what happens when machine learning is used. Both high hazard hit rates are nearly doubled. Leveraging machine learning, the same number of safety officers can conduct approximately 16 high hazard inspections for every 100 inspections. It helps us to more effectively get the right people to the right places at the right time. And what about remote assessments? Let's take a look at that at the next slide. Similar to the previous two graphs, this one also presents the information in quarters, starting with the first quarter of 2019 and extending to the end of last year. It shows the number of assessments that were conducted year over year. Prior to 2020, all our inspections were conducted in person. The numbers are a bit difficult to read, but the significant drop about a third of the way into the chart was the second quarter of 2020 when COVID hit. The health restrictions negatively impacted our assessments and the presence of our safety officers in field. By the third quarter of 2020, however, safety officers were conducting remote assessments. As our tools improved and health restrictions eased, safety officer presence increased and then exceeded where they were prior to COVID. Combined with physical inspections, remote assessments have enabled us to increase inspection numbers by about 10% compared to where things were before COVID, and presence by about 5%. With these technologies enhancing the knowledge and expertise of safety officers, we've been able to deliver more with largely the same resources. Additionally, Technical Safety BC hasn't received fatal incident reports and technologies that have the model fully implemented, and the efficiency of the risk-based model has enabled us to focus on larger safety issues elsewhere, including work done outside of the safety system and newly emerging issues. That said, we continue to seek the right balance between mitigating safety risk and unproductive friction. But what do you think? What does it mean for you to have a regulator use technology to enhance safety at scale? So thank you for joining us today and spending some time to learn more about assessments. With that, I'm going to pass the mic back to our host, Janice Lee.
Thank you, Lisa, for that great presentation on our assessment program. We are now going to open it up for our question and answer period. Thank you for those who have put some questions already in advance, and I encourage folks who are participating to continue to do so. So I will read out the questions, and either myself or Lisa will be able to answer them. So the first question is for Lisa. Could you please confirm risk-based assessment operations presented in the slide is applicable for all pressure equipment installed and operated in British Columbia?
Yeah, that's a great question. So pressure vessels, and we categorize this under boilers, pressure vessels, and refrigeration. They all fall under the same regulation. It's one of our technologies that we're working on getting into the structure resource allocation program. We have some risk-based mechanisms there, but BPVR tends to be much more complex than electrical or gas systems, in part because it captures multiple types of technologies and systems within the same regulation. And then also because of the number of codes that get adopted and are applied across all of these systems and equipment. And so creating a risk-based approach for BPVR pressure vessel equipment is much more complex. We're working on that, and there is some risk-based assessments there. But for installation permits in particular, we are largely on a compliance model at this time.
Thank you, Lisa. And I will actually take the next question as it has to do with the elevator inspection remote assessment app that we piloted last year. So it's a question regarding the elevator inspection app and some of the concerns raised about issues with during the trials, as well as, how do we verify who's doing the assessment, and how will Technical Safety BC rule out the possibilities of potentially folks cheating in using the assessment. So a couple of things. One is what we piloted last year was really the front end for our clients to be able to take pictures and basically submit us the information. This year, we are going to continue to be working on the back end of the whole process, where those pictures will then be sent to our safety officers so they can evaluate and determine if the assessment is complete. So there is definitely more to come in terms of the development of the overall app, and we will be reaching out to our clients once we have done the full program, and again, from a piloting perspective, so that again, we can evaluate what some of the things we may need to improve on, and then we will make some decisions around if we actually roll this out full scale. So definitely more to come, and we will be in touch with the elevating industry, specifically on the construction hoist app. So thank you for that question. So I have a question for Lisa. So this is again around elevating. So it's a question around, where is there a requirement for asset owners to hold an operating permit? Sorry, if we could actually bring back that question, because I didn't actually get a chance to fully read them. So maybe I will just move on to the next question. If Rachel on the line can actually bring it back for me, that would be great. Which was the question around elevating operating permits. So the next question is also for Lisa. So if I could just finish reading it, is first, how will Technical Safety BC address safety officer resourcing to make safety officers more available during normal working hours for remote assessments?
Yeah, that's a really great question. And certainly as we come out of COVID and we're looking at when it's most appropriate to use physical inspections and when it's most appropriate to use remote or other tools entirely, we do need to create some structure and parameters around what gets used when. So that work is being done right now. And in the coming year and years, I should say, we have planned what's called determining our assessment roadmap. And so part of that will be looking at safety officer resourcing, availability, and then also when physical and remote inspections get used, and what's the right guardrails for each of these items. We certainly don't want to be pitting resourcing against safety risks. What we want to do is be clear on the level of safety risks and how we can adequately resource all of the risks across the spectrum, but certainly attending to high risk items. So that's something that we have ongoing discussions on, and we also have it planned as a project coming up to determine it in a more structured way.
Great, thank you, Lisa. So I'll just go back to the question before around elevating for Lisa. So this is a question regarding operating permits for asset owners. So the question is, where there isn't a requirement for asset owners to hold an operating permit, Do sites without current or valid operating permits get flagged as a higher risk and therefore have safety officers conduct a site inspection?
So where there's a requirement for the asset owner to hold an operating permit,
Right,
just besides,
and there is not a valid operating permit at these sites. Would these
right,
sites therefore get flagged as higher risk and therefore have a safety officer conduct a site assessment?
for sure. Yeah. So um, the requirement for operating permits varies a bit across technologies, and elevating the required across the board. And so we do check on both installation and operating permits. And when there is regulated work or equipment being operated that doesn't have the permit, our safety officers will conduct inspections, usually physical in-person inspections related to what's called an unpermitted work file. And so those in our system are UWs, and they generally fall into that channel of SRA that we refer to as hazard eliminations, because work without a permit, the required permit, generally carries a greater risk and then therefore hazard. And so they do get flagged, but it is a different channel versus a typical inspection.
Thank you, Lisa. So this is another question for you. This is in particular about remote assessments for pressure equipment. So the question is, National Board, which is the NBIC under RCI interpretation, allows remote inspections of pressure equipment. What is TSBC's position on this interpretation? Could you please confirm?
That's a very good question, and one that doesn't have a very easy answer, unfortunately. We have looked at the many different codes related to boiler pressure vessel and refrigeration equipment. And we are also in the process of looking at it more closely related to project work that we're doing around mandatory inspections. And so it really is dependent on the context, the type of equipment. But there are areas where we bump into codes and what needs to be inspected in person, what's acceptable to be done remotely. And even for in-person inspections, we also get into some gray areas where, is supervision something that has to be done in person, eyeball to eyeball, or is supervision adequate if someone is available by phone or by email? And so those are very nuanced areas of interpretation, and it really requires an understanding of the specific context, the technology, the unit that's in question as well. So I can't speak to across the board interpretation, certainly on national board, but if you had a specific scenario, please, I would encourage you to reach out to either your local safety officer or myself, and we also have an engage email as well.
Thank you, Lisa. So I have a question here for yourself. It's about when a building permit is required for a voluntary fire alarm panel. And so there is quite a bit of detail here, but it just sounds like there's a situation where in the city of Coquitlam, there's a requirement for both an electrical permit from our side, and then there still is a requirement for the city of Coquitlam for a building permit. So it seems quite confusing.
I'm not sure what the question is there.
I think the question is about a building permit and how that is the crossover between an electrical and building permit.
Okay. Yeah. So Technical Safety BC oversees the electrical aspects of permitting across the province. There are some exceptions with certain municipalities, but by and large across the province, we do not oversee building permits, which are generally municipal. And so we do get into some areas like this where there are requirements that can seem redundant. Where that's the case, again, we encourage people to reach out, but also to reach out to the other overseeing body, in this case, the city of Coquitlam. And we are certainly open to working together to streamline these processes so that it doesn't feel redundant, and so that we are able to oversee this on our side, the electrical safety aspect of it, but also the other organization gets what they need in order to meet their mandates. So I can't speak right now on the city of Coquitlam's requirements related to building permits. But again, I would encourage you to reach out and we can track down some clearer answers for you there and look to ways for improving that.
Thank you, Lisa. And we have about 5 more minutes before the end of the Q&A. So I have a couple more questions here in the queue. So Lisa, this is another question around remote assessments. And so it sounds like there's some challenges for a client when there's a remote assessment and they have to return to a client's home for obtaining pictures. They do not always find it practical to return to the client's home, especially if they are more remote. So they're asking for, how do we explain to the homeowner when the work has completed, and we have some challenges around returning to site.
For sure. I absolutely empathize with those challenges. When we first started conducting remote assessments, it was largely a response to COVID. We had a pilot project at the time, but we certainly didn't anticipate that we would be using it to the extent that we are today and needed to use in order to address the health restrictions. Since then, our tools have improved quite a bit. If you go onto our website, there are guidelines related to each of the technologies on what's expected with a remote assessment. And so there are guidelines around which photos to take, what documentation might be needed, and really walks you through some of the items related to work or installations. If you follow those guidelines and submit those information on the front end to your safety officers, it becomes a lot easier to be able to get through the remote assessment process. It's not, we're working on streamlining it more so that it becomes simply a part of the declaration process, like we've done with elevating and construction hoists, but we are still figuring out how best to roll that out across other technologies and inspection types. Where the work has already been completed and folks are needing to go back to site and it's a barrier, or sometimes it's even a different owner, reach out to your safety officers. We don't want to be in a position where we're sending you back to do an insurmountable amount of work. Talk to your safety officers, and if a physical inspection is needed, our folks can still go out to do those. So the key piece here is communication, trying to do that work on the front end to provide the information according to the guidelines. And where it's passed and we're already at the inspection stage, communicate with your safety officers and we can work to get to a mutually acceptable solution.
Thank you, Lisa. I have a couple more questions for you here. So there's a question around, is there any real penalties for consumers or contractors not abiding by the permit process?
Yeah, for sure. So in the earlier main session, you heard from our VP of Regulatory Leadership about our compliance and enforcement department. And so we do have another arm of our organization that follows up where people aren't doing the work that they're supposed to be doing. It can be a very, very frustrating process for people who are doing what they're supposed to be doing. And then, of course, these files, once we receive them, go through a rigorous review. And we do have tools like discipline orders, compliance orders, monetary penalties, among other things that we do impose in circumstances where it's warranted. And so there are penalties. There's information on our website on each of these, on these items, and then also on our compliance and enforcement work as well.
Thank you, Lisa. And I'm actually noticing that we're almost at time. We do still have some additional questions, and what we will do is post the and answers on our website after the session is over. So apologies for not getting to all of them, but I also appreciate the engagement and the questions we're receiving. We will definitely give you the answers you need. So once again, thank you so much for participating in this session with us today. We hope this presentation has been valuable. We definitely invite you to get in touch with us and continue to engage in these conversations with us. And lastly, once the session ends, you will see a survey link on the screen. We would really appreciate if you can take a few minutes to complete it. Your answers will really help us adjust and improve future events like this. And so again, thank you so much for your attendance and participation and your very thoughtful questions. Thank you and have a great day.